All right, I'm making this video in case we have an e-learning day on Wednesday, February 10th. If you're watching this for some reason and it's not that situation, it's nothing you need to watch. I just forgot to delete it, I guess. So what I'm going to do in this video is go over your homework from Tuesday night, and then I'm going to assign a worksheet with the same type of questions. Hopefully you remembered to take your graphing paper home. You should have, because I either gave it to you 6th or 7th period today, but if for some reason you don't have it and you have a printer at home, I will attach just some blank graphing paper that you can add to it, that you can print off and then do your homework on that as well. So let me work through these 8 problems. If I have you 3rd or 5th period, there's a couple of them on here that I didn't get a chance to do examples of. I did in 6th and 7th period, so 3rd and 5th period people especially pay attention. I think there's one on each page here. So, all right. So this one says 2x plus 3y is equal to 12. So this is in standard form. A would be 2, B would be 3, and C would be 12. So we'll just quickly make a little t-chart. And if x is 0, that means I can cover up the 2x because it's going to go away. And we'll solve for y. So I have 3y equals 12. Divide both sides by 3, and you'll get y is 4. So that means that the y-intercept is 4. All right. So we've just found a y-intercept. Now we want to find the x-intercept. So I do that by letting y be 0. So if I plug in 0 here, this will end up going away, and I'm left with 2x equals 12. Divide both sides by 2, and I get x is 6. So now I have an x-intercept of 6, which is right there. The minimum you need to graph a line is 2 points. So we have what we need. And drawing our line, make a big nice line, not a little baby line. And there we go. All right, this one says x minus y equals -5. So we'll make another little t-chart over here. I'm gonna go shake the mouse so it doesn't shut off on me. If I let x be 0, I have -y equals -5. So -y equals -5, that's a ninja 1 right there. If I divide both sides by -1, I get rid of this negative, and I get y is a +5. So that means my y-intercept is +5. If I let y be 0, that literally says x is -5. So -5 is my x-intercept. And we end up with this line here. All right, these are numbered weird. I must have taken this from an old review or something at one point and was too lazy to change the numbers. That's why it starts with number 17. But that's the first 2 you had for homework last night. So let's scroll down to 19 and 20. Yeah, number 20 is one of them that maybe gave you some trouble last night. So we'll look over to that one. Now, if you look at 19, it's technically speaking not in standard form. The reason why is because we have this negative right there. However, you don't really have to do anything about it. It'll still work to graph it. Later on, we'll probably learn how to fix that, quote unquote, and put it in proper standard form. But as far as graphing it is concerned, that negative is not really going to change anything. So I'm going to let x be 0, so I'll cover up the x term, and I get 3y equals 24. Divide both sides by 3, and I'll get a y-intercept of 8. So that would be right there. And now I'm going to let y be 0. I'll get negative 4x equals 24. Divide both sides by negative 4. And I get x as negative 6. So there's 3, there's negative 6. So there's an x value of negative 6. And let's draw our line. And there we go. All right, number 20. This is one of them that third and fifth period I ran out of time and didn't get a chance to do one like this. So there's our original. And this one isn't in standard form either, but this one we do have to do something about. And the problem is this term right here. Remember, regular standard form, I sure hope you can see up that high. Let me see here. Oh yeah, most definitely can. So remember, regular standard form is ax plus by equals c. So we need our x term on the left, and currently it's on the right. So since I don't want it there, I'm going to get rid of it. And the way to get rid of negative 3x is to add 3x. But I have to balance out my equation. So if I add 3x to the right side, I also have to add 3x to the left side. So that's going to eliminate it from that right side. Now, 9x and 3x are not like terms, so they're not going to combine. I'll just have to rewrite that as 3x plus 9y. And the only thing we have left on the right side is negative 18. So now that's that same equation that we started with, but in standard form, and now I'll be able to graph it very easily by finding the intercepts. So when I let x be 0, divide by 9, and I get negative 2, so we have a y-intercept of negative 2. And when I let y be 0, divide by 3, and I get an x value of negative 6. So there's my two intercepts. And there is our graph. Right, so that takes care of the third and fourth ones you were supposed to do for homework, which are number 19 and 20. So let's get these erased and move on to the second page. All right, we have 21 and 22 from last night. On 21, we have 4x plus 5y equals 8. This might be another one that gave you guys some fits. Not because the math is challenging, but because it turns out kind of weird. So if I cover up x, I'm left with 5y equals 8. If I divide both sides by 5, well, 5 doesn't divide into 8, so I get 8/5, or what is 1 3/5, or what is 1.6. All right, I'm just going to put 8/5, but when I go to plot that y-intercept, well, 1 3/5 is somewhere between 1 and 2, but ever so closer to 2. So I'm just going to kind of guesstimate where that is. So that's my y-intercept. And I'm going to end up, no I'm not, this one will end up just fine. If I cover this up, I get 4x equals 8, so divide by 4, and I get an x-intercept of 2. So there are both my intercepts. go through both of them. And there's my line. Number 22, we have negative 6y plus 3x equals 12. If it bothers you that the x and the y are flipped around, you can change them. Just remember 3x is positive, so it's going to stay positive. Negative 6y is negative, so it'll stay negative. In other words, negative 6y plus 3x is the same thing as 3x minus 6y equals 12. So we'll make our little table here. I'll move that mouse to get that shadow thing to go away. Cover up x because x is 0. Divide both sides by negative 6 and I get a negative 2. So y value of negative 2. Let y be 0. I get 3x is 12. Divide both sides by 3. And I get an x-intercept of 4. Excuse me. So now I'll put up my straight edge and drawing a line. So there's the graph of numbers 21 and 22. So we should only have 2 more to go from last night's homework. All right, number 23. So it has a lot going on. It's not in standard form, and once we solve it, it'll give us kind of weird intercepts. So let's handle that one. We have 7x equals 6y plus 10. So the 6y is the problem this time. To get rid of positive 6y, you subtract 6y, but I have to balance my equation by doing the same thing to both sides. Positive 6 and negative 6 cancel each other out, so then I'll be left with 7x minus 6y is equal to 10. So if I make my little t-chart, when x is 0, I'll be left with negative 6y equals 10. Divide both sides by a negative 6. Y will be equal to negative 10 sixths, which reduces to negative 5/3. So that would be negative 1 2/3, or negative 1.6 repeating. Okay. I like to just put the improper fraction, negative 5/3. That's going to be somewhere between 1 and 2. I'm sorry, somewhere between negative 1 and negative 2. A little bit closer to negative 2, so I'll just put it right there. When x is 0, when y is 0, ooh, rough here. When y is 0, we'll cover up the thing with y. I get 7x equals 10. Divide both sides by 7. And x is 10 sevenths, or 1 3/7. I'm not even going to pretend to know what that is as a decimal. Something a little bit smaller than 1.5, probably like 1.4 something. But whatever, it's somewhere between 1 and 2, a little bit closer to 1, but almost in the middle. So I'll just, I had that wrong. That was my y-intercept. Sorry about that. My y-intercept of negative 5/3 should be between negative 1 and negative 2, a little bit closer to negative 2. Sorry if that confused you. And then the x-intercept of 10 sevenths should be somewhere between positive 1 and positive 2, a little bit shy of the middle. I'm glad I caught that. That could have been bad. And there's our line. All right, and the last one, number 24. That one says negative x plus 2y equals negative 3. Once again, that's technically not in standard form because of that negative right here. But also, don't worry about fixing it. It's not going to matter. It'll still graph the appropriate way. So if I let x be 0, I'm left with 2y equals negative 3. Divide both sides by 2. And I get negative 3 halves, which is negative 1.5 for the y-intercept. Let me put that in the right spot this time. And when y is 0, I get negative x equals negative 3. So divide by negative 1. Those will become positive, and this will become positive. So I get a positive 3, which is right here. And there's our line. All right, so in this same Google Classroom post where you found this video, you should also find a new worksheet for homework. So that'll be what is due tomorrow. Try to get that to me as soon as you can. I strongly prefer that you upload it to Google Classroom, but I know for some of you that's not an option or an easy option. So emailing me would be an okay alternative as well. So that'll wrap it up for your Wednesday, February 10th video. Hopefully I'll see you in person tomorrow. I don't know what the weather's going to do. When you see tomorrow's video, or if you see tomorrow's video, I'm going to be in the same clothes. I'm making them the same night, so don't think I'm dirty and not showering or something. All right, see you guys. Be safe.